Welcome. In this video, we're going to learn about a very special member we can assign to our custom classes, the constructor. To start off, let's take a look at the code in front of us. This program creates an instance of our custom class person and immediately assigns some values to person's member variables, first name, last name, and birthday. Then we utilize some of person's member functions to print out some information about the values we've just assigned. The thing is, while this is a decent program that we've just written, it's easy to see someone making a mistake writing even this simple program. For example, what if I had forgotten or simply didn't realize that birthday was one of a person's member variables? If I didn't assign a birthday to a person right away and then attempted to use the .age member method, our program would crash when it attempted to access that birthday variable that had not been set to anything. This is a very reasonable mistake for a programmer to make, both in terms of not knowing that they should set this member variable to a value and also in assuming that this member variable would have a value, because what person doesn't have a birthday? Fortunately, there's a system in place where we can demand information from the user before we allow them to even create an instance of our object. So let's jump into the code that declares the person class and set this class up so that a person can only be created if it's given all of the necessary information right from the start. To do this, we're going to use a constructor. A constructor declaration looks a lot like a normal method declaration, except for one thing. Where a normal method would have a return value, even the value null if it wasn't designed to return anything, constructors don't even have that. Also, the name of the constructor method is the same name that we've assigned to our class. However, just like normal methods, we can give constructors input. To start off, let's assume that all persons have a first name and a last name and a birthday. Otherwise, they simply shouldn't exist. When we create a new instance of the person class, and the person class has a constructor defined, we will always create an instance of the class using the person constructor. If we save this update to our person class declaration and then go back to the main method of our program, we'll see that we're going to get a compiler error if we run this code now. That's because we modified the person class to demand that our newly created constructor be used. That constructor takes three inputs, a string, and a calendar. So, instead of modifying person's member variables in these three lines of code, what we're going to want to do is pass these three variables as arguments to our constructor method. Now, as far as the main method in our program is concerned, the syntax of our program is once again valid. Of course, if we run this program, we're going to run into some troubles because while we pass these arguments to the person constructor, we haven't yet done anything with them. Now, it needs to be the job of our person constructor here, as opposed to the main method in our Java program, to translate these parameters into the values of the person's member variables. So let's do that. Let's change our person's first name, or rather set its value, to be the variable passed in to this function. Now, this is technically correct syntax that we have here. It will do what we want it to do, but it should give us some pause. The command first name equals first name is really, really weird, and it's pretty ambiguous if you go about reading it. After all, which first name are we talking about in each of these instances? Are we talking about person.firstName, the member variable of this class, or are we talking about the first name that was passed in as arguments to the constructor method? To disambiguate this, we can do a couple of things. First off, we could simply change the name we assign to our method arguments to be something that's not identical to the local member name. But sometimes it just makes sense to explicitly ask for a first name. It can be a lot easier for the people who are going to use the constructor. When we need to explicitly tell our program then that we're using one of person's member variables, we should path to it properly. The this keyword will allow us to access the class that we're currently operating in, or rather its object instance when the program runs. So this.firstName will always reference the member variable as opposed to the one passed in as an argument. Now that we have that syntax down, we can very quickly assign the argument values to the values of our member variables. Now, when we save this file and go back to our main method and run our program, we'll get the original output, showing us that our person constructor has properly mapped these input values to the values stored in our person object. So this is pretty cool. We've modified our person class so that it's much, much more difficult for a programmer to make an obvious mistake and call these methods when they're bound to fail. A programmer could still get in trouble if they did something along the lines of modifying one of the member variables after our person has been created. However, there's a system in place for us to protect our classes, if we choose to, from having their members modified without going through proper protocol. Let's say that we'd like to change our person class so that the only time these members are ever changed is once, at the very beginning when the constructor calls. If you'll remember, we've been tagging all of the members of our classes with this public protection tag. Something that's tagged public is basically viewable whenever by any piece of our program that has access to its container. However, we can use a couple of other different protection tags. If we were to tag all of our member variables private, then they would only be viewable within the context of their current class. So we could still use these member variables in our person constructor and our full name and age methods. But this line of code here, where we attempt to access last name outside of the actual class declaration, would now be invalid. We can tag members private and then instead create public methods to modify their values when appropriate. And by doing so, protect our objects from ever being given invalid values. Now, let's go back to talking about constructors before we wrap up here. As with normal methods, we can override constructors and have more than one option for our programmer to choose from. For example, let's say that sometimes in our program we want to create new people who have just been born. In this instance, it might make a lot of sense for us to construct a person by simply giving the first and last name to our constructor, and then having the birthday be a new Gregorian calendar, which will default to today's date. If we wanted to use that constructor instead in our program, we'd simply call the constructor with only 2 string arguments, which would map to the newly created constructor that we've declared here. And when we run this program, we'll see that John Doe is now 0 years old because his birth date has been set to the current date and time. Lastly, we can give someone the option of utilizing one of our constructors or simply creating an instance of the class without doing anything, simply by declaring a constructor that is empty. Then that syntax looks just like the creation of John we had earlier. Generally, we don't want to do this though. What we want to do if we have an empty or a default constructor is to assign default values to our member variables so that at the very least we're still not breaking our program. So it might make a lot of sense for our default constructor to assign empty strings and maybe today's date to our first, last name, and birthday fields. Then, even if our programmer doesn't properly assign values to John's fields after creating them, there's still going to be some valid values to those fields to protect us from actually throwing an error when we run our program. So that's the skinny on constructors, another tool that helps us protect and make more robust the code we've already written.